Now we're going to look at an example of completing the square where our a value is not 1. Step 1 when we're completing the square is to move our constant to the other side. So I'm going to start by adding 27 to both sides. That gives me f of x plus 27 equals 3x squared minus 24x. Step 2 says to factor out any a value that's not 1. In this case, our a value is 3, so I'm going to factor out that 3. I'm not taking out a GCF, I'm just taking out that a. So now we have f of x plus 27 on the left, and now we factor out our 3. When we divide everything by 3, we're left with x squared minus 8x. Now we're going to look at our b. Whatever b is left over after we factored out a, divide by 2 and square it. Negative 8 divided by 2 is negative 4. Negative 4 squared is 16. Here's where things get a little funky. When we're adding 16 on the right side, we're going to add it inside of our parentheses. So here's our plus 16. But we have this 3 in front of our parentheses. If you were to distribute this 3, we would have to multiply 3 and 16 to get rid of our parentheses. Well, 3 times 16 is 48. So really, we added 48 to the right side, which means we also need to add 3 times 16, aka 48, to the left side. So anytime that you have this a value, you're going to have to multiply it by whatever your b over 2 squared was. If this a value was 2, I would put 2 times 16. If my a value was negative 5, I would put negative 5 times 16, because we want to keep our equation balanced. On the right-hand side, we added 3 times 16, so on the left-hand side, we need to add 3 times 16. Now let's do some simplification and some factoring. So on the left, we have f of x plus, and 27 plus 48 is 75. Equals 3, and now I'm going to factor this trinomial. So what are my factors of 16, positive 16, that add up to negative 8? That would be x minus 4 and x minus 4. And now we can move the 75 back to the other side. So we're left with f of x equals 3 times x minus 4 squared minus 75. So we know our vertex by switching our h sign and keeping the sign that goes with k. And that is the vertex of this quadratic.